So acids. This is about acids, all acids, the properties, the behavior, and how do we detect acids. Now, what is common in all these substances? We have oranges, we have lemons, we have oranges, lemons, we have tamarind or imli, oranges, lemons, tamarind, we have vinegar, so oranges, lemons, tamarind, vinegar, and we have curd. So oranges, lemons, tamarind, vinegar, curd. What is common in all this? And you have got a hint. A property which is common to these but which is not found in sugar and salt. It's not found in sugar and salt, but it is found in all the other substances. What is common? Obviously it is they are sour in taste. All of them are sour to the taste. And again we can show them that this is sour, this is also sour, tamarind is obviously sour, vinegar is also sour, and curd is sour. All these substances are sour in taste. So all these substances which are sour are containing acids. All the substances that are sour contain acids. And acid comes from a Latin word which means sour. Now, how do we classify acids? Acids can be classified in many ways. You can classify acids in many ways. One of the ways of classifying acids is as inorganic mineral acid or organic acids. Inorganic acids are very strong. We can't drink them because they could burn our skin and mouth. They are so strong that even if you touch them, they could burn your skin. Organic acids are weak. We can touch them, we can eat them, we can drink them because they occur naturally in plants and animals. For instance, oranges, limes, pomelos. These are citrus fruits and contain citric acid. Citric acid is an inorganic acid. They are weak. We can eat oranges. We can eat lemons. We can eat pomelos. We can eat all the other fruits because citric acid is an inorganic acid. It's weak. They will not damage our skin or tongue. We can drink the juices of these, orange juice, lemon juice, because they are weak and do not damage us. Now these are some vitamin C rich fruit. Oranges, the avla or olive, these are substances rich in vitamin C, and there is a tablet of vitamin C. They all are sour in taste because they contain ascorbic acid. Ascorbic acid is another name for vitamin C. Ascorbic acid is another name for vitamin C, and vitamin C tablets are also sour in taste. Here we have tomatoes, which contain citric acid, malic acid, and oxalic acid. And we also have apples, which contain malic acid and ascorbic acid. And as we saw, ascorbic acid is another name for vitamin C. Ascorbic acid is another name for vitamin C. But these substances also contain citric acid, malic acid, they are sour in taste. But they are weak acid and they will not damage us, our skin or mouth or tongue, and we can touch them, we can eat them, or we can drink their juice. Here we have some more acids. This is the tamarind or imli, which contains tartaric acid. Here we have vinegar, which contains acetic acid. Next we have curd, which contains lactic acid. Our own stomach, it produces hydrochloric acid. And red ants, the bite of red ants, we feel the burning sensation because of formic acid. So this is tartaric acid in imli or tamarind, acetic acid in vinegar, lactic acid in curd. Our own stomach produces hydrochloric acid and red ants producing formic acid. Now, although hydrochloric acid is a strong acid, still the stomach produces the acid in very dilute form, and it is not damaging until it is in excess, when we can get gastritis and ulcers. So these are organic acid. Now the three most inorganic mineral acids. Inorganic acids are also called mineral acid. You got hydrochloric acid, sulfuric acid or oil of vitriol, and nitric acid. These are the three most important inorganic mineral acids. And you have seen that the inorganic mineral acid are usually very strong and could burn our mouth if we drink them. It could burn our skin if we touch them, and often we have a warning: highly corrosive, can cause severe burn or damage or burn injury. Next we come to acid-base indicators. Acid-base indicator. Now how do you know if a substance is or has an acid? You are saying lemon has citric acid. How do we know that? We say curd has lactic acid or vinegar has acetic acid. Now how do we know if a substance is an acid or substance has an acid? One is by sour taste. But we can't taste every substance. For instance, hydrocyanic acid or prussic acid is instantly fatal. It is deadly. It is poisonous. So we can't be tasting every acid. Then how do we know that something is an acid? We use certain chemicals called acid-base indicators. Acid-base indicators. They will change their color, which will help us to know it is an acid. The acid-base indicators are chemical substances which will change their color, and when we see a change of color, we can know that it's an acid. They are called acid-base indicator. Substances which change their color when you put them in an acid. One common indicator is litmus. Litmus. Now it is extracted from a symbiotic alga-fungus association. It's called symbiotic because the alga-fungus association is a mutually beneficial association. Alga helps fungus, fungus helps alga. Alga is green, it can photosynthesize and it supplies food to the fungus, and fungus is non-green, it cannot make food, but it holds water. It keeps the alga hydrated. So alga gives food, fungus gives water. So this is how the mutually beneficial association is called a symbiotic association. And here we get the common indicator called litmus. So one acid-base indicator is litmus. Litmus solution is mauve or purple in color. and it is deep purple in concentrated form. Normally in dilute form it is light purple, but it is deep purple when you concentrate them. In acid medium, its color changes to red. And in basic or alkaline medium, it changes to blue color. Acid medium, it gives red color, and basic or alkaline medium, it gives blue color. Now conveniently, litmus are made into red and blue litmus papers. There is the papers, litmus and blue litmus papers, which come in strips. Red litmus paper will change to blue in alkaline medium, like soap solution. Blue litmus paper will change to red in acidic medium, like hydrochloric acid. So here we have a strip of red litmus which changes to blue when you put them in an alkaline solution. And here we have a blue litmus which changes to red when you put them in an acidic medium. So red color of the litmus will show it is an acid. Another common indicator is methyl orange. It's a synthetic compound you made by adding sodium nitrite to sulfonylate acid. Means it's not extracted from plant or animal. It has to be made in the laboratory. It gives a red color in acid medium and a yellow color in basic medium. In acid medium, methyl orange gives a red color, and in basic or alkaline medium, it gives an yellow color. So there is a methyl orange in red color in acid medium and yellow color in alkaline medium. Now another indicator we are going to use is a natural indicator, petals of China rose or hibiscus. These are the petals of hibiscus. These are the petals of hibiscus. These are the hibiscus flowers. Now petals of this flower we soak in warm water. We put them in warm water and wait for some time until the solution is light pink. With acid it turns deep magenta, and with base it will turn light green. Deep magenta color will indicate acid and light green color will indicate its base. So this is how we are getting the acid. So this is what we are getting. This is the neutral solution. What color it is? It's light pink. When you add them to acids, it becomes deep magenta. And when you add them to base, it becomes light green. So light green color of the China rose petal will indicate base, and deep magenta color will indicate it is an acid. So China rose petals can be used as indicators. All we have to do is soak the petals in warm water and wait for some time until we get a light pink solution. Now sour taste is an identifiable property of the acid. It's not the definition of acid. It's only one of the properties of an acid. An acid has several properties. It can react with metals and produce certain changes. So sour taste is only one of the properties. How do we define acid? An acid is a substance. That in aqueous solution gives hydrogen ions as the only positive ions. An acid is a substance that in aqueous solution gives hydrogen ion as the only positive ions. Now, hydrogen ions are called protons. Why they are called protons? This is a hydrogen atom. It contains one proton and one electron. So when this electron is removed, it becomes an ion, then only proton remains. Originally, the hydrogen atom had one proton and one electron. When this electron was removed, then hydrogen ion means only proton. So hydrogen ion can also be called protons. Now hydrogen ion will combine with water to form hydronium ion. When hydrogen ion or proton combines with water molecule, it forms hydronium ion. So instead of hydrogen ion, we can replace this with hydronium ion, or we can also replace with the word proton. Aqueous solution means when dissolved in water. So what we wrote, in aqueous solution, we can replace this word with when dissolved in water. An acid is a substance. When dissolved in water, we can write instead of aqueous solution. Positive ions means cations. So we can also write as the only cations. Instead of positive ion, we can write cations. This we wrote, we can also write cations. So instead of the positive ion, we can write cations. But the word only is important. This word only, which is important, this is the word only we are getting. This word is very important. This word is important. Why it's important? Let us see. Now, suppose we take a solution of sodium hydrogen carbonate. Sodium hydrogen carbonate. In old books, it was called sodium bicarbonate. The new name is sodium hydrogen carbonate. When you dissolve in water, it will give two kinds of cations, hydrogen ion and sodium ion. Hydrogen ion is a cation, positive ion. Sodium ion is also positive ion cation. Now, it is not an acid. It gives hydrogen ion, but it is not an acid. Why? Because hydrogen is only one of the cations. There are two cations. Hydrogen is only one of the cations. That's why we have to write the word only. It should give only one cation, not two or three cations. It should give only one cation. It should give only one and only one cation, and that should be hydrogen ion. That is the importance of writing only. So when we say, we have to use the word only. Hydrogen ion as the only cation, or hydrogen ion as the only positive ion. If it gives hydrogen ion and sodium ion, two cations, it's not an acid. Hydrogen ions are essential for acid behavior. This is actually the ion, this hydrogen ion. This is responsible for all the acid behavior. So a perfectly dry sample of HCl gas will show no acid behavior. It will have no reaction on litmus or methyl orange or even your China rose petals. In aqueous solution, when it breaks into ion and gives hydrogen ion, only then it will show all the acid behavior. Similarly, carbon dioxide gas, perfectly dry, it will not show any acid property. When you dissolve in water, it forms carbonic acid. See, this is how it forms carbonic acid when dissolved in water. There is carbonic acid. And then it dissociates or breaks up to give hydrogen ion, and then it will show all the acid behavior. So hydrogen ion is absolutely essential for acid behavior. In perfectly dry condition, that is dry HCl gas or perfectly dry carbon dioxide gas, perfectly dry SO3 gas, they will not show any acid behavior because they will not give hydrogen ions. Now we saw one way of classifying, that was organic acid and inorganic acid or mineral acids. Now there are other ways. We can classify acids as concentrated and dilute. It depends on the proportion of water. Concentrated means more acid and less water, and dilute acid will contain more water. strong and weak acids, and depends on how many of the molecules ionize. Here we have the figure. Here see, almost all the molecules are broken into ions, and here very few of the molecules are broken into ions. When all the molecules or most of the molecules break up into ions, we get a strong acid, that is a large number of hydrogen ion. When very few molecules break up, we get very small number of hydrogen ion, and that's a weak acid. So strong acid, we have most of the molecules ionize, so you got many hydrogen ions. Weak acid, very few molecules ionize, so very few hydrogen ions available. We can also classify acid as monobasic acid. Monobasic acid means it will give one molecule will give one hydrogen ion. One molecule will give one hydrogen ion. Dibasic acid, one molecule gives two hydrogen ion. And tribasic acid, one molecule will give three hydrogen ion. So that's actually we had about acids. Thank you. For more information or more videos, WhatsApp us. Thank you and goodbye. Hope you enjoyed the lesson.